sometimes when we see flowers, we feel like, oh, this flower has life of only 2 days. Oh, I'm sorry for it. Maybe universe also looks at us in a similar manner, like, oh, this person has life of 100 years only. Our stars have life of billion and billion years. Maybe they feel like that, but the point is that when you see the flower, and if the flower has a beautiful fragrance, we admire that fragrance. The point is to be like that much beautiful that if you don't even matter in this big universe, but everyone will admire your good qualities. So always try to be a person which has a beautiful surrounding, means not like beautiful surrounding, who makes his or her surrounding beautiful with, and fills the environment with fragrance, right? So actually we are going to talk about escaping from earth, not uh, some spiritual and meditation. We are going to talk about the orbitals, the spaceships, space stations. In particular, we are going to talk about with what velocity, if we will travel, we will escape from our earth. So in the last lecture I was talking about non-inertial frames and all. In that lecture I said that I will talk about space stations in upcoming videos. So today we are going to talk about space stations, how they free fall when traveling along orbit of earth, and orbital velocity. So if we want to escape from earth, we will need some velocity. Let me show you something. When let us suppose this is ground. When we throw a ball, it will go something like this and fall, right? If we increase its velocity, the path will look something like this. We know that our earth is spherical, right? So the path, this ground looks straight because we are just throwing this ball in a very small distance. If we increase the distance, it will look something like this. Here the path will look something like this, right? And if from here I throw a ball, here now it's trying to fall, but as the ground is curved, it is not touching the ground, right? I hope you are trying to understand. I am able to make you understand that when we increase the velocity, that the ground looks a little bit curved, the ball is unable to reach the ground and travels with a velocity and is under a gravitational force towards the center, but is unable to touch the ground because the ground is itself being curved. The ball is not able to touch it, right? I hope this is clear. You can see some animations to visualize it in a better way. So what is this velocity? That the ball will just orbit the earth. We will talk about it later, but first let's talk about what is the velocity to escape from earth. If we want to escape from earth, we will have to do some work, right? We know about work energy theorem. So when we have some velocity, we have some kinetic energy that will be equal to half mve, escape velocity square, right? And the work done against the gravitational force. So what is gravitational force? Gmm by r square, or the square of distance. Let us suppose I am here at a distance r. I am trying to escape from Earth. So I am trying to escape from Earth at initial distance of r from center. After some time, this may be r plus some d, some r plus some dx, and more. Let us suppose this distance, a random distance from Earth after some time will be x. So I can put here distance from the center of Earth at a random moment be x. So g mm by x square be the force. We know about work done. What is work done? Work done is force into displacement. So let us suppose this displacement is dx. So we can say that g mm by x square, the force times dx, is the small work done, that is dw. So what will be the total work done? When we want to escape from Earth, we have to reach a distance of infinity. Infinity, I had told you about what is infinity. Infinity means a relative concept, that where the distance of the point from center of Earth is a large distance for the gravitational force to be experienced. So initially the point was at r, finally it will come to infinity, and we will call that it has escaped from the Earth's gravitational field. So we can put the limits. The work done initially was 0, and we need the total work done W to travel from r to infinite distance. So we can integrate it. It will be equals to W, and here we can say that g mm is constant mass of Earth, mass of the object or Earth, universal gravitational constant, and here we have to integrate 1 by x square. So we know the integration formula, that is x to the power n plus 1 divided by n plus 1 minus, it has the power of minus 2, means minus 2 plus 1 minus 1, that is minus 1 by x from r to infinity. So we can say that this will be equals to minus 1 by infinity. 1 by infinity is equals to 0 minus of 1 by r, means plus 1 by r, that will be equals to g mm by r, right? So we can equate this kinetic energy with this work done. We know the work energy theorem, that is change in kinetic energy equals to the total work done. So we can say that this work done equals to this kinetic energy, that is g mm by r. So from this we can calculate velocity, because if we cancel the same, although we know our mass, but still let us cancel it and see that v square will be equals to 2gm by r, right? So here VE will be equals to under root 2gm by r. Note this formula down, because sometimes we will need to talk about escape velocity of some other planets in some numericals. So this equation is useful for when we talk about some other planets or stars or something else. And for specifically talking about Earth, we know that g mm by r square equals to small g, that is the acceleration due to gravity. We know that this is the force, we know that g mm by r square is the force, and from this we can say that the acceleration will be equals to, when we divide this mass of the body, this will be equal to acceleration, that is small g. So here we can put small g instead of g m by r, that will be equals to v e equals to under root g m by r will be equals to, here taking 1 r to the right hand side, g m by r equals to g r. So we can say that escape velocity for Earth is under root 2 gr. And you know that from this equation we can see that the velocity is dependent upon the mass. Means a heavier planet will have a higher escape velocity, means it will require a much higher velocity to escape from a heavy planet such as Jupiter, but it will take a lower velocity to escape from a small planet, and just like Mercury. And you know about black holes. Black holes is a planet where escape velocity of black hole is equals to velocity of is greater than velocity of light. That's why even light cannot escape from black holes, right? If the light wants to escape from black hole, it has to have a greater value than that of speed of light. But we know that speed of light is a constant value, which is a limit that no one can cross, means no one can have velocity more than light. But we don't know what is physics, means I want to say that we don't know what will be discovered in the next generation, means physics is unsolved till date, I can say that. So be much flexible to accept whatever theory comes into the ground, right? I just want to say that don't believe anything blindly. Even I guess Einstein had also said that common sense is a big problem. So don't always use common sense. Try to go beyond theories, think beyond what you are studying. So these theories apart, we are going to talk about the equations. So we need to actually we travel with a velocity of 60 km per hour, right? When we are traveling to our destination, but that much velocity is that much distance need to be covered in 1 second to escape from planets. I guess it is the escape velocity of Jupiter 60 or 59 some 60 or 59 km per hour, and 680 km per 60 or 59 km per second is the escape velocity of Jupiter, and 680 km per second is the escape velocity of Sun. You can check it out, or I will drop this information in the description box. So this is all about the escape velocity. But when we want to just orbit Earth, means just like space stations. Actually, this is the situation of space station. Here the space station is likely to fall down, but as the surface is curved, it is unable to fall down, and it is continuously in free fall. Here the space station is trying to fall, but it is unable to fall because the surface is curved. But still the gravitational force is working on it, a force which is the force of free fall, right? So here the astronauts feel a free fall in space stations. And for what is this velocity? So to orbit Earth, when in the last lecture I was talking about non-inertial frames, so I guess you know about pseudo forces. If not, let me tell you about that. When we talk about a non-inertial frame, that the frame is accelerating, it will experience a pseudo force on it, right? So let us suppose a satellite is orbiting Earth here. So here a outward force of mv0 square by r. mv square by r, here v0 is the orbital velocity denoted by O. So this much force will act outwards, that is centrifugal force. We know that a centripetal force, a inward force act on a body when it is in circular motion, and this is the centrifugal, that is the pseudo force, because this body will say that I am at rest. For every body, even if it is moving, it will feel that I am at rest, but the reality is that it is not at rest. And for non-inertial frame, when this thing arises, the body shows that a pseudo force is acting on me, that's why I am feeling that I am at rest, but that is not the truth. So this pseudo force should be equal to the gravitational force, right? That's the centripetal force. We know that the planets or this satellite is orbiting Earth, or Earth is orbiting Sun due to gravitational force, because the gravitational force is acting as the centripetal force which keeps it in the orbit and makes it orbit the path. So this should be equal to the gravitational force, that g mass of Earth into mass of the body by r square, right? From this we can cancel some values and get that v naught square equal to gm by r under root. We know that gm by r equals to small g, that is acceleration due to gravity, into gr for Earth, and this is for, you can use this equation to calculate the orbital velocity of other planets while doing numericals. So we know that escape velocity is under root 2gm by r, orbital velocity is under root gm by r. From this we can calculate the ratio of v by v naught, which will be equals to root 2, right? This implies that v naught equals to 1 by root 2 escape velocity. Here we know that this thing will be less than 1, because root 2 is greater than 1. So from this equation you can see that orbital velocity is less than escape velocity. It is also really very easy to understand that to escape from Earth we need more velocity than to orbit it, and this value is, as I remember, 0.70 something. So v naught is less than velocity, escape velocity. We have some cases for this situation, that if the velocity is less than orbital velocity, the object thrown or the object moving will go in a elliptical path and fall on the Earth. But if velocity equals to v naught, it will move around Earth in a circular path. But if velocity is greater than v naught but less than escape velocity, it will move around Earth but in an elliptical path. And if v equals to v escape velocity, it will just escape from Earth in a parabolic path. But if this velocity is greater than escape velocity, then it will escape from Earth in a hyperbolic path. We'll study about these cases, why this path is actually elliptical or hyperbolic or parabolic, while talking about Kepler's law. So after studying Kepler's law, we will able to understand. Now you know about that Earth orbits Sun, right? And this path is not actually a circle, it is an ellipse, right? This is a semi-major axis, this is a semi-minor axis, this is Earth, this is Sun. Here at this point where it is at the point where Earth is farthest from Sun, it has a larger velocity, smaller velocity, but when it is nearest to the Earth, nearest to the Sun, it has a higher velocity. Means you can understand it like when it is at further distance from Sun, the gravitational force decreases, therefore the velocity decreases, but when it is nearer to Sun, the gravitational force increases, and because the distance decreases, and due to the increase in gravitational force, the velocity increases. You can understand it by this concept, and we will talk about this thing while studying Kepler's law, and we'll understand how aerial velocity is constant for planets orbiting Sun. I will tell you about what is aerial velocity. Aerial velocity basically means that it will cover same amount of area in same time interval. You can also see that. Let me draw an ellipse. If this is ellipse, and here the body, the satellite or the Earth is traveling with a smaller velocity, means it will cover a small distance and just something like this. But as this thing is large, the semi major axis, so total area will be large. But here, as this thing is small and velocity is high, it will cover a large distance in same time interval. But as this is along semi minor axis, the axes are small, so this area will be equal to this area. We'll talk about it later while studying Kepler's first law, second law and third law, and we'll derive it mathematically. So this is for today. We'll talk about some more interesting facts in upcoming lecture. Till then, stay tuned and thank you.